a big scary math problem showed up. It's huge, it's hairy, and it looks like this. But guess what? This monster is just wearing a costume. Underneath, it's a really little baby math puzzle we already know how to do. Let's take off its mask together. So let's have our first example. In this example, we will solve for x to the fourth power, or x raised to 4, minus 9x squared plus 20 equals 0. And as you can see, this problem looks confusing because it has x to the fourth power, right? Also, we have also x squared, like two monsters playing dress up. Let's look closely. Hey, both of those are made from x squared. So let makes our life easier and say, we will let x squared equals the big Y. Now, x to the fourth is just y squared, right? We will change this as y squared. So, now we will rewrite the equation. We will rewrite this one as x squared. So we have it's y squared, the big Y, minus, since our x squared is just y, this one will change 9y. Okay, 9y. Plus, this 20, there's nothing to do with 20, so we'll write 20 here. Okay, so that's way easier to look at, right? So let's proceed to the next step. Our next step is to solve the easy puzzle. So we ask what two numbers, okay? So what two numbers multiply by 20 and add up to 9 or negative 9? Let us try 4 times 5. Okay? 4 times 5 is 20, right? Also, we have 4 plus 5. But 4 plus 5 is not negative 9. Okay, it's 9. But however, let us use the negative sign. How about negative sign? Negative 4 times negative 5 is 20. Correct. Negative 4 plus negative 5 is equal to negative 9. So, we have our two factors. Our two factors are y minus 4, okay, because we use this one, okay, and the other one is y minus 5, okay, and that is equal to 0. Again, so the factor is y minus 4 minus times y minus 5 equals 0. And now let us solve or find the y. Set each part equal to 0. So our ZPP rule. So y minus 4, okay, this one, we will set that equal to 0. Also, the other y would be y minus 5, and we will set that equal to 0 as well. This one and this one separated. And now let's go back to x, okay? By the way, before we go back to x, let's find out the y. So when we find the y, we must add 4 both sides, or basically transpose negative 4 to the other side. So we have y equals, this one will cancel, 0 plus 4 is 4. And we have our first y. And our second y, we have 0 here. We will add 5 both sides. And our y would be, this one will cancel. 0 plus 5 is 5. Okay, we have 2y. Let's go back to x. What is our x here? Okay, remember, we said y is equal to x squared. So now, x to the x squared equals 4. So we have x. The y will be replaced by x squared, right? Again, because our y is equal to x squared. Okay, so this y, the big y, will be x squared, and that is equal to 4. Okay, so another y would be, another big y will change to x squared as well, and that is equal to 5. So let us find out our x squared here. Okay, so we can easily cancel this one. We can easily remove the square by applying the square root principle, right? So when we have x squared equals 4, okay, it will also equal to x, and the square would become positive or negative square root of the constant. The constant is 4. Okay, there are two possible answers. Plus or positive square root of 4. By the way, square root of 4 is a perfect square number. 4 is a perfect square number. It can be written as positive or negative 2, like this. Okay? Or the two possible answer would be x equals positive 2 or x equals negative 2. So I can write it down here. X equals positive 2 or x equals negative 2. Okay, so we have our two x's here. Now let's try to add the other one. So we have x squared equals 5. Now we want to apply the square root principles once again here. So we have x equals positive or negative square root of the constant, square root of the constant, square root of 5. Or the answer would be, since 5 is not a perfect square number, the answer would be x equals positive square root of 5. Or x equals negative square root of 5. Okay, so we have 4 x's, right? So the 4 x's here is 2, negative 2, square root of 5, and negative square root of 5. These are our final answers. Okay, so let's move on to the next one. So for the next one, we solve x squared minus 3 raised to 2 minus 3 quantity x squared minus 3 plus 2 equals 0. Whoa. This problem looks like a birthday cake with too many layers. But look, the piece x squared, this one, x squared minus 3 shows up again and again, right? But now we will call that piece as c. Okay, z. So we will let z or big Z, I would rather say big Z, be our x squared minus 3. Okay, this is the magic. Now, the giant cake becomes this two thing will become Z, capital Z squared minus 3. And this one will change as Z as well. Plus 2 equals 0. Again, to review this part of our equation, we will change it as big Z. Okay? Because they look the same, right? Now, our next step is to solve the easy puzzle. So what multiplies by 2 or to 2 and adds up to negative 3? What do you think? Let's try out. So let us use negative 1 times negative 2 equals, okay, negative times negative is positive, 1 times 2 is 2. Okay, let us try to add them. Negative 1, okay, plus negative 2. And that is equal to negative 3. So, our two factors are z minus 1, which is this, plus, times z minus 2 equals 0. Or, our z here, z would be, okay, let us write, let's write here, our z minus 1, that is equal to 0. Okay, using ZPP, z minus 2 equals to 0 as well. Or our z would be positive 1. Okay, that is our z. And the next z would be z equals positive 2. Because we will transpose it to the right side by adding to both sides. Okay, so let's go back to x. We said earlier that the z is x squared minus 3. So what will happen? Since z is equal to x squared minus 3, so now we can write it as this one. We will change it as x squared minus 3 equals 1. Okay, again, the z will change or will go back to x squared minus 3. Okay, and the other z here, this one, also we will write it as x squared minus 3 as well equals 2. Then we solve for our x. So we want to add 3 both sides. Okay, we have x squared equals 4. And applying the square root principles, we have x equals plus or minus square root of 4. And we simplify, x equals plus or positive or negative 2. Square root of 4 is 2. And this is our first 2x. And the other one, also, we do the we simplify this one. We have x squared equals this negative 3 will be transposed to the right side. It will become 3 plus 2. 3 plus 2 is 5. Okay, so x squared for x, applying the square root principle, would become positive or negative square root of 5. Okay, again, our answer is x is equal to positive or negative square root of 5. It can be positive, it can be negative, or positive or negative square root. It's positive or negative 2. Okay, so that is our second example. Example number 3, we have x minus 6 square root of x plus 9 equals 0. And this one has a square root of x. That means what numbers or what number times itself makes x. Now let's give that square root a nickname too. So the nickname would be let m. Okay, let m. This one would be square root of x. Okay, that nickname or the nickname of square root of x would be the big M. Now let's give that square root of x, or let's rewrite, since m is equal to square root of x, then our x is equal to m squared. Okay, it's just like a reverse process. Like again. So for you to visualize, m is equal to square root of x. For us to find the x here, we will just square root both sides. So basically remove the square root, and x would be m squared. And this one. Okay, this is it. So now, let me erase this one. Now we will change the things in our original equation. Our x here, okay, so that disguised to m squared. Okay, m squared. Again, our x is m squared. So we will change x as m squared minus. We have 6, but our square root of x would be m, right? And the positive 9 or plus 9, okay, we have nothing to do with 9 or positive 9, so we will just copy, and that is equal to 0. Now, so look at this equation, and this is, I believe, a perfect square trinomial. So we can factor this one that adds up, that multiplies to 9. Okay, two numbers that multiplies to 9 and adds up to negative 6. And the factors are m minus 3 times m minus 3 equals 0. And again, when we check, negative 3 times negative 3 is 9. Okay, multiplies to 9. Negative 3 plus negative 3 is negative 6. Okay, so they are the same. So we said m, okay, m, when we apply the zero product property, minus 3, that is equal to 0, then m is equal to positive 3. Okay, because whatever m minus 3 there, the result would be the same. M equals 3. So let's go back to x. We said m is equal to square root of x. So now square root of x, okay, square root of x equals 3. Okay, so we change m as the square root of x, right? And that square root of x would be x equals 9. Why? Because we want to change, or we want to remove the square root, okay, by squaring both sides. Okay, so as we square both sides, we will cancel this one, and the remaining would be x equals 3 squared. 3 squared is like 3 times 3. Okay, 3 times 3, that is 9. Okay, the answer would be x equals positive 9. So you did it. Okay, as we wrap up, since we did it already, all 3 scary looking math problems is just a puzzles in disguise. As we did was, number 1, give tricky pieces a nickname. Number 2, solve the easy version. And number 3, go back and find x. You're now a math monster buster. And next time math looks scary, just give it a nickname.